Hello and welcome to time series forecasting. In the previous video, I talked about augmented Dickey-Fuller test to test for the stationarity of any time series. In this video, I'm going to talk about another test that you can apply, which is called the KPSS test. And it is based on some of different assumptions than augmented Dickey-Fuller test. Now there are a bunch of other tests that you can use to test for the stationarity of the data set, but most of the times in time series analysis, KPSS test is preferred. Now the null hypothesis for this test is the stationarity in the data set, which is different than the null hypothesis in the augmented Dickey-Fuller test, where the null hypothesis was non-stationarity, and we look for the evidence of the rejection of this null hypothesis, which means a very small p-value, that is the p-value less than 0.05, suggests that our time series is non-stationary, and we need differencing to make this time series stationary. So let's go to R and let me show you an example in R of how to execute this test in R. To run this test, we need this library URCA. I'm going to run this library, and then we are going to work with the same data set. First, I'm going to generate 1000 random numbers, and then I'm going to use this function ur.kpss, which will evaluate this time series based on the null hypothesis of stationarity using KPSS test. And then we are interested in looking at the summary of this test. So looking at our calculated t-stat, which is 0.13, it is less than the critical values here, which means we fail to reject the null hypothesis of stationarity, and we conclude that this series is level stationary, or I0, that this series is integrated of order 0, and it is stationary to begin with. We do not need differencing of this series. Now let's look at another example of another series, and in this case our test stat is very large and it falls into the rejection region, and because it is greater than these critical values, which means we reject the null hypothesis of stationarity in this case, and we conclude that this series has a unit root in it, and this series is non-stationary, and we need differencing of this series before applying a Riemann model. So this is the way of applying KPSS test for the detection of stationarity in a time series. Alright, I'll see you in the next video. Bye bye.